we want to find the moment of the force, that 400 Newton force, about point A, knowing that this is 40 degrees here. Okay, so when doing this, the easiest way to do it is break up your r vector, your moment arm, and your force vector, the 400 newtons, into x and y components. And we're basically going to take perpendicular distances. So, for example, this force right here will break up into 400 cosine 40 in the horizontal going to the left and 400 sine 40 going down. Okay. Now, again, the moment is the moment arm from the point to the force uh, along any line of anywhere along the line of action of that force. So, for example, I can extend this horizontal force, the 400 cosine 40, anywhere along that horizontal axis. So I want to find the r vector, the perpendicular distance from the point to that line of action of the force. Essentially, I'm going to bring the force over along that line and find that perpendicular distance. Okay, so for that one, okay, the the moment about point A for that component of the force will be 2 meters times 400 cosine 40. It's the vertical distance times the horizontal force. And that's essentially what we're doing. We're taking a vertical distance times a horizontal force, and then a horizontal distance times a vertical force, and adding them together. Now, we need to take into account what direction this moment is in. And you see that this is going to be in the counterclockwise rotation, which we assume to be positive. That's the sign convention. A counterclockwise rotation is positive. So this is a positive moment about point A for that horizontal force. So I take that vertical distance times a horizontal force. Similarly, I can extend my vertical force here, and I can draw my r vector, my moment arm, from point A to anywhere along the line of action of that force. So again, it's a vertical force. I'm going to draw a horizontal distance like I have right here. Okay, so again, this will be perpendicular. That force is essentially this way. It is also a counterclockwise rotation about point A, so we call that a positive. Now this is going to be that horizontal distance, 3 times the vertical force, 400 sine 40. And this is essentially what we do to find a moment in 2 dimensions of a force. We take a horizontal distance times a vertical force and a vertical distance times a horizontal force, breaking those pieces up and then adding them together. And when I do that and I multiply those and add them together, I get 1384. And my units on this will be Newton meters, force times distance. And that's positive because it's counterclockwise, both of them added together.